Hello. Sneha, should we check the video?
Yes, 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 sir.
Can you give me the so that I can just check?
Um, Sorry, can you repeat, sir?
Can you give me the sharing permission? Can I go ahead in
Yes,
sharing?
yes, sir. Please do.
Is my screen visible?
Perfectly. Yeah.
Okay. So my voice is clear, right?
Yes, sir. Very clear.
Thank you very much.
Thank you.
Okay, then I will unshare now. So the moment you tell, then we can do that. Okay.
Perfect. Yeah, we'll start sharp at 1 o'clock Philippine time. Thank you.
Sure. Thank you.
All right. Good afternoon, everyone. On behalf of Apex Global, we warmly welcome you all to our July Xposium with the title Smart Solutions for Energy Efficiency in Heavy Industries. So join us for a transformative webinar diving into the realm of energy efficiency. And in this 1 hour webinar session, we'll tackle the importance of energy efficiency, best practices, and case studies on implementation of energy efficiency projects in the cement and steel industries and the latest innovative technologies for industries. So come on, hop in and let us elevate your understanding of energy efficiency and unlock its full potential for your business success. Now, to introduce our speaker for today's Xposium, Mr. Muralikrishnan, Principal Counselor at the Confederation of Indian Industry, is a seasoned leader with over 20 years of expertise in energy efficiency, certified as an accredited energy auditor by the Bureau of Energy Efficiency. He has conducted 200 plus detailed audits across diverse sectors, including cement and thermal power plants. His work, supported by UNIDO, focuses on advancing practices and promoting renewable energy adoption, highlighting his influential role in shaping energy policies with innovation. Mr. Sougata Sarkar brings a wealth of expertise in energy efficiency and sustainable practices. Currently serving as senior counselor at the Confederation of Indian Industry, he has played pivotal roles in various high-impact projects across India. Certified as an energy auditor by the Bureau of Energy Efficiency, he has spearheaded studies on hydrogen-based steel production and facilitated Indo-Swedish collaborations. Without further ado, I will turn the floor over to our speaker, Mr. Murali and Mr. Sougata. Good afternoon, everyone.
Good afternoon.
Yeah, good afternoon. Thank you, Apex team, and give me a minute so that I will share my screen. I hope my screen is visible.
Yes, it's up.
Yes.
Yeah, thank you. So once again, good afternoon to all. Thanks for joining this webinar. I'll just have some few slides on introduction, not too much, and then I will straight away get into what are the opportunities we can start improving, considering in major industry. So we are from CII, the Confederation of Indian Industry, the largest and the oldest industry association in India, with more than 8,000 organizations being a part of our membership. We have about 67 offices in India. India is a big country, so we have also what is called the unique Center of Excellences. The general officers do the General Industry Association activities, whereas the Center of Excellence provides technical services in specific activity. For example, whichever technology we want the Indian industry to adopt in future, whichever technology is upcoming, whichever area is important, so we focus on that technical area. Each Center of Excellences provide opportunity and provide the capacity building and ensure that Indian industry gets the right technology, prepares well for implementing that technology. So CII serves as a reference point for Indian industry and international business community. Okay, so these are the centers of excellence spread across the country. In fact, there are 12 centers, including skill, women leadership, logistics, quality. It covers a variety of sector areas, and we are from the number 6 CII Shorabji Godrej Green Business Center. We have been operating from 2004 for the last 20 years, and this year, July 14th, we are celebrating our 20th year of operation, and we work on all activities related to green. That is our this thing. The uniqueness of our building is the first platinum rated green building. A green building by definition can save 30% energy, 40% water, and then it also reduces the resource intensity, and not only green by word, but it can also provide you cost benefits and environmental advantages. It can improve your brand image. So that is the thing. And it was the greenest building in the world when it was inaugurated in 2004. But now it is one of the greenest building in the country, and first platinum rated net zero energy building. So the entire building is having 124 kilowatt solar panel, including bifacial solar panel, vertical solar panel, hybrid power, which produces 20% more power compared to a conventional solar panel technology, and we generate more power than what we consume annually. So that makes our building a net zero energy building, first in the country of India. So these are the services or initiatives what we do. We not only do initiatives, but we also measure and verify what is the stakeholder, how much they have achieved, how much cost benefit they got. So we have the green building getting promoted. So when we wanted to promote green building, our building was constructed as green 20 years before, and we have more than 12 billion square feet in India today. And we have a holistic rating system for companies, manufacturing companies, wherein we help them to do a manufacturing process in a more sustainable way with cost benefits. And then we also have a product certification, which is again recognized by the GEN Global Eco Label Network, which is recognized by more than 100 countries across the globe. So more than 5,500 products have been certified. All these products are used in the buildings, green building. Of course, I am from the energy efficiency team. Our energy efficiency activities are 3 decades old, and we have done more than 2,000 plus energy audits. These are not only the A-level audit, it is a 3-level audit, C-level audit, where when we go into micro details. I will explain that further in our case studies. We have done more than maybe 1,300 programs in energy efficiency. We also work with startups accelerating clean tech. In fact, the startups in India, we promised them 5x growth. India is a big market for energy efficiency and for everything. So we promise, and we have supported more than 30 startups them to achieve 5x growth in their turnover in 3 years, as long as they are related to energy efficiency. These are the verticals that are delivered from our Center of Excellence. And then not only we do those activities, but these are the sub-activities. We cover the entire spectrum of technical areas related to green. Is it whether it is related to GHG inventorization, whether it is energy efficiency improvement, decarbonization roadmap for organization. We have developed in 2013 for the Indian cement sector a low carbon technology roadmap, which aims to reduce the emission intensity by 45% 10 years before. And now we have, in the last year, we have done a roadmap development for Dangote Group, one of the biggest cement producer in Africa, having operations in 11 countries with 13 plants. We have developed them. We have just concluded that decarbonization roadmap, and then help them to set targets for 2030, 2040, and then for cycle assessments. We have developed the country-specific data sets for cement, steel, coal, power, and construction material, including concrete, in India in the past. And we are also part of the global EcoInvent database network. And we have also done a lot of validation and verification of GHG studies. We also facilitate ISO 50001. And then India has a unique scheme called Perform, Achieve, and Trade, wherein the major industry of almost from 24 sectors, 1,000 industries are mandated by the government to set and achieve a target. And if they exceed a target on energy emission, specific energy intensity, they can trade the excess certificates available, similar to carbon credits that was done earlier in the world. And then, of course, through all these activities and with your support through our partners, we also do capacity building of our stakeholders in the efficiency, GHG, and life cycle assessment. And with more specific to energy efficiency, we have a team of 40 people, and we have 3 decades of experience. We have done the audits close to 2,000, and we have also taken feedback, and we are continuously in touch with the audited stakeholders. They have achieved about more than 3 billion Indian rupees of annual saving. And we also have a annual award wherein the companies come and present their best practices. We also create a platform where the latest technology providers come and display their technologies. So as I said, when I said the 3 decades of experience, you may get a question like every 3 years, is there any new thing that is getting developed? What we have seen, what I have personally seen in the last 15 years is every 3 years, the technology is emerging and it is crossing a new boundary. And then I'm associated with cement industry for the last 25 years. I have seen in every decade, the energy consumption comes down by 30%. There are a lot of new initiatives taken up by the industry, and then they maintain the operating cost, they maintain the margin of profit, and they are also able to grow. Indian cement industry is the second largest industry in the world, cement industry in the world, with an annual growth rate of close to 8%, because India is still developing the infrastructure requirement. The per capita consumption is still only 250 kg per person per year, so which has a high potential. It has the potential to double. So that involves that. I just wanted to say that energy efficiency is continuous and there is a huge scope. Even today, the Indian cement plants operate almost 60 units to 70 units per ton of cement, whereas the global average is close to 100 units. And the Indian cement plants were also at a similar position 20 years, 2 decades back. Taken a lot of initiatives, including the blended cement, including the energy efficiency, adopting the waste heat recovery, adopting the renewable energy, improving the technology. Some of the case studies we will see today. And it is not only in cement sector, whether it is steel sector, whether it is copper, whether it is automobile engineering, whether it is aluminum, fertilizer, textile, sugar, we see a lot of potential happening. As I said, this year we are celebrating the silver jubilee of our energy award. In this energy award event, the countries across the sectors, more than 15 sectors across the country, they come and participate. They compete with a global or with they compete nationally with an intention to showcase their best practices, the energy efficiency measures adopted, and also learn from each other. So CII, being an industry organization, industry association, we create this kind of platform so that there is cross exchange of inputs, technical learning from various sectors that helps them to become competitive nationally and globally. And this also provides a lot of opportunities to our own technical team to learn. So that is the point we have mentioned here. Irrespective of the sector, irrespective of the equipment, we see there is always continuous improvement happening across the last 20 years. So that is what I wanted to say. Irrespective of whichever sector you are operating, is it a building, or is it a major industry, or a cement industry, or a steel industry, people are continuously improving, because one of the fundamental reason is the cost is increasing. We have not only worked in India, but we have also worked across the globe in various countries, including Japan, Korea, Philippines. Philippines, we had the opportunity to visit and then conduct audit in 2 of your sugar plants, 2 of your power plants. We had a lot of opportunities. We have done in Malaysia, Indonesia, Thailand, and the African countries as well. We have done, we are also trying to do an audit in US, and then we are improving. Efficiency is important. So people say the climate change, the only 2 buzzwords which are happening across the sector, manufacturing sector, also the think tanks and the stakeholders. One is climate change. The other one is startup and incubators or innovations. Innovations and startup is one word which is most popular today in the globe. And then second is the climate change, which we all know the reasons. So we need to sustain the world. We need to give the grandchildren a better world. For that, we have to take action. And internationally, all the stakeholders, all the think tanks agree that energy efficiency is the most competitive solution and still has close to 40% of opportunity of reducing the emissions most economical way. So that's why we need to focus on energy conservation and energy efficiency, and it also supports us in energy security, business sustainability, and as well as it can be the best tool to achieve ESG, where we have environment, society, of course, the governance is replaced by economics here. But in all the 3 ways, all the 3 circles, this is a central area where the energy efficiency can definitely lead to sustainability. And we felt that 1.5 degrees will come at the end of the century. But what is happening is the scientists predict that by 2027 itself, the Earth temperature will increase by 1.5 degrees. We are already having 428 ppm of CO2 in the atmosphere, which is alarmingly high. And whatever actions we are taking is not sufficient. We need to accelerate our actions. Many of our countries are targeting for net zero. Also would have announced it. India has announced the targets. of becoming net zero by 2070, which is still far away, but still we need to do a lot of work on that. And then, as I said, the 1.5 degrees is going to come in 2027. We need much stronger, much deeper, and much bold efforts to do that. Energy efficiency is one of the easiest, one of the most economical, and one of the most promising lever tool. So that's why we all need to take on this. And it's not only the sustainability which is most important, but also to sustain the business, to become more competitive, to keep the margin, and then to reduce the operating cost. We need to focus on energy efficiency. As I said, in India, the energy cost is very high, just like Philippines, in the other developing countries and developed countries. So to compete, to be there in the market, become the leader, people focus on energy efficiency. 35 to 45% can be more on in a cement plant. In a steel plant, it can be 40% to 50%. And then in a paper plant, it can be 25 to 30%. And then further, there will be carbon taxes, there will be other requirements, which will all increase our cost of manufacturing. So energy efficiency, by definition, is the process of getting more output with the same input, or reduced input for a same output. So that is what is needed. So we have been discussing on this, so I don't want to repeat this. So we need to focus on energy efficiency. And as I said, for decarbonizing, which is the most important goal of our generation, 40% can come from energy efficiency at a most economical way. 30% can come from material circularity, and then 20% can come from renewable energy, because renewable energy is not very attractive, whereas energy efficiency is the most attractive tool to decarbonize our emissions. And then the energy efficiency can also be done by all the three methods. One can be capacity utilization. Maybe some processes need 100% capacity utilization always. Some processes we can optimize what is the optimum capacity. And then, of course, fine-tuning. What we strongly believe and what we have understood and what we have experienced is every equipment, every process has a margin. The margins are built because by the plant people, by the designers, by the technology providers, and by the consultants. Of course, so why margins are kept? Margins are kept to meet the immediate future requirement, varying climate changes. For example, all of us are experiencing extreme hot and extreme flood and extreme winter. So the same equipment, for example, HVAC system in a building has to adopt all these conditions. Even in Europe or even in colder regions, now the temperatures are going up to 40 degrees. So the same equipment has to deliver 40 degrees. It also has to deliver for 2 degrees or -5 degrees. So the equipment has to have a margin. So the operational plant or the operating team, the working engineers in the plant, in a manufacturing plant, their intention should be to fine-tune the equipment according to the current level of production, current level of demand, and current level of operational requirement. So that's why fine-tuning is most important, and energy audit will mainly focus on fine-tuning. Of course, on capacity utilization and then fine-tuning. And then the third most important lever is, as I said, the technology is evolving. A lot of new startups are coming. A lot of, for example, artificial intelligence and machine learning is coming up. So whenever it is economical, we also need to upgrade our technology. So all the three will result in energy efficiency, energy conservation, and can be used as a tool. In a study, when we reduce the energy conservation, or when we focus on energy conservation or energy consumption, the audit team will definitely focus on all the three, not only on fine-tuning, not only on capacity utilization, but also on the technology upgradation. So we have seen all the excellent companies who are global best or international leaders in energy efficiency. They have three separate teams with a common objective, and they have tapped all the potential. So let us see some few case studies which can be related to technology, which can be related to capacity utilization, which can be related to fine-tuning. For example, this is a small operational performance. So in cement plant, we have cooling fans, which are we are supplying atmospheric air into the cooler. So if you see, the purpose of the cooler fan is to supply atmospheric air into the cooler for the whatever Pascal or pressure needed. Ideally, the suction should be because the air is taken from the atmosphere, the suction pressure should be 0. But you can see in so you can see in that plant, all the 6 fans have a pressure inlet varying from 77 mm to 160 mm. So ideally, because the fan is taking suction from atmosphere, it should be 0 or minus 20 or 30, but it is very high. So that consumes a significant portion of the energy consumed by the fan. The fan is consuming, say, for example, 185 kilowatt per hour. 19 kilowatt is additional or excess because of the high suction. So this is a clear case where 10% of the power is lost because of the improper designing of the suction. If the suction is properly designed, it should be minus 20. But because it is having a silencer which is not working fine, design of the inlet suction, the pressure is going to minus 160, which is equivalent to 10% of the power consumed by the fan. So of course, you can quantify that for an 8,000 hours in a year and then multiply by 10 years into your energy cost. This can be a significant amount. So what we can do? So this is an opportunity where there is an improper design, and it is also a typical example of fine tuning. So what we have to do, the radius of the inlet should be 0.25 times the effective diameter. That is the recommended value. So during the audit, we can check what is the pressure, what is the saving potential, and what is the problem in the design, so that can be eliminated. Now, this is the case study of a plant where they have invested $6,000. Of course, these costs vary from country to country, because in some plants, the manpower cost is very cheap, the equipment cost is relative. Maybe in some markets, the cost of equipment can be very low. But what is important here is the idea and also of the implementation. This project or this opportunity doesn't need a major modification. It is very simple technology, and this can be easily identified, and this can be implemented in a very quick way. And most important is it has a very high attractive payback period. The payback period is less than a month, maybe for Indian conditions, maybe for international conditions. We have seen this in South Korea, Indonesia, Malaysia, etc. Maybe the 1 month can become 5 months, but still it is very attractive. Similarly, the latest technology, if we talk, there are a lot of tools, artificial intelligence tools, say IoT tools, which can help us in fine-tuning the process conditions. For example, in any manufacturing process, whether it is cement, paper, steel, etc., there are fluctuations in the plant. These fluctuations operate in major important loops. For example, the PC outlet versus outlet temperature, coal feed rate. So which is very important, which is most important process parameter. We have to maintain the calcination, which is important for the kiln to give a good quality clinker and to maintain the output. So the temperature is controlled with the coal feed rate. Of course, many things can vary. So this is a practical loop of a plant, PID loop, where you have the temperature versus coal feed rate. You can see the fluctuations. Okay, so if you have this kind of fluctuations in your process parameter, so obviously this is your alarm limit, or this is your, say, set point. The operator will always try to keep a margin, and because the fluctuation is very high, so he will not be able to put that in automatic mode. So he will be operating that in a manual mode, so which will increase our specific energy consumption. There are a lot of latest tools available, so which can collect the data in a more to your PLC, which can capture from the screen, MMI screen, and then the tools can tell you how much is the problem in the fine tuning. This can also tell you, is that the problem in the process itself? Is it the problem of the CV of the coal? Is it the problem of the temperature sensor? It is the problem of the solid flow meter which is supplying the coal? Is it a mechanical wall problem? Is it a process problem? Is it a fine tuning problem? Whether you are proportional, integrated, derivative, set points, how much you have set, all these can be done without disturbing the process in a remote sense, and a weekly progress report can be done. And at the end of the day, when you fine tune it, so definitely the loop can become stable. So this has been implemented in more than 50 cement plants in the country. They have achieved about 2 kilocalorie per kg of clinker, which is significant. The benchmark, the PID standard deviation has come down from 0.9 to 0.0, so which has resulted in better operation, better quality clinker, lowest energy consumption, and then better savings. So these are all some examples. In a KC firing, this was the earlier variation, and then after fine tuning, after taking action, the variation has come down. So this has saved 2.38% of energy, which is significant in an annual basis. So this is what can be done with an automated tools. This is another opportunity wherein we can see just using a tool which is of latest technology without disturbing the process offline, we will be able to save some energy. So the savings is very attractive, 500,000 US dollars with just investment of 130,000 US dollars, which again doesn't need any stoppages, doesn't need any disturbance to the process. This can help us in getting the payback period less than 2 months. And then the other opportunity is the entire cement industry is only gas and material. So the pressure drop plays a very important role. The fans consume about 25% of the total energy consumption. The fan energy consumption, it depends on the pressure. So during the study, we can see the pressure drop across the ducts, various ducts. So here in this case, the downcomer duct is having a high pressure drop. We can measure the pressure drop across the cyclone, various process equipments, and then compare them. And then we can get into further details. Is it because of the velocity? Is it because of the false air? Is it because of the material accumulation? And then in this particular plant, though the velocity is only 13 meters per second, which is acceptable, the pressure drop across the duct was more than 110 mm, and then 80 mm in the downcomer duct. So that was significant. And what they did, they used CFD, computational fluid dynamics, to study the flow performance, and they have then taken some action. And then that action implementation has resulted in a power reduction of about 160 kilowatt per hour, which is very significant, which is equivalent to 100,000 US dollars in a year. Again, in this case also, the payback period is less than 6 months. So I'm saying it is not only an auxiliary area, an important process area, important process parameter can also be analyzed and optimized. And then the other thing is, we also get into deeper process conditions. For example, in any preheater, the overall heat transfer, the purpose of the preheater is to preheat the material from the hot gas available in the kiln process. Okay, the heat transfer happens mainly in the riser ducts, whereas a cyclone is a gas solid separating equipment. The moment the gas and material enters the cyclone, the material gets separated from the gas stream. So in this audit, what we have done, we have just seen what is the effectiveness of this heat transfer in the riser duct. How close are we utilizing the entire length of the riser duct? How close is the feeding point? So we have studied that, and we have recommended, and then the plant team has shifted that location to a lower location. Thereby, we are utilizing the entire heat transfer area. It increases the residence time. It improves the heat transfer. Thereby, the heat losses coming from the preheater has come down. This is a perfect process optimization example. So this has resulted in 130,000 US dollars with an investment of 75,000 US dollars with a payback period of 7 months. So not only we focus on electrical energy, we can also focus on thermal energy. We can also get into the minute details of each process area. And then, so having the primary air burner. So burner is a key component. We have already invested. We may be having the latest technology, but what we should also see is what is the percentage of primary air. In this case study, in this plant, they were having 14.5% of primary air, which is very high. So this can be compared with the various available technologies in the market. What is the recommended value? For example, that plant we just saw, it was 14.5%, whereas the best available technology in the market is only 5% to 6%. So which means that we are not adopting the latest technology. If we have the latest burner, then we should optimize it to the best possible. So that has resulted in saving potential. And then in this case, see, because they were not having the latest technology, they were recommended to go for the latest technology, which can significantly reduce the primary air from 15% to 6%, which can give them a very big saving, as well as high production possibility. Productivity improvement is possible, and also this can also reduce the carbon emission significantly. Of course, this needs an investment. The payback period is slightly longer, but we should also identify opportunities where latest technology can be implemented. And then we not only focus on thermal energy in pyro section. This is another example of a raw mill, wherein we study what is the importance of the gas flow. The gas flow in a vertical roller mill depends on 3 parameters. Either it could be because of a drying requirement, or it can be because of the separator requirement, or it can be because of the temperature, or for example, the loading of the separator. So the latest technology is to study the gas stream. For example, in a conventional separator, the flow of the gas will not be in a uniform way. You will see red color, very high velocity zones. You can see a lot of turbulence. You can see a lot of recirculation. This will increase the pressure drop across the mill. So the recommendation was to go with the latest technology, vortex rectifier, so that this can be reduced. So these are the opportunities. These are the various examples. For 3 decades of experience, and because of 200 cement plants in the country, we can also give you a lot of references. We can also make you to visit with the plant. We can also make you to interact with the team who have implemented. So that will increase your confidence, and that will also give you feedback what in the best possible way you can implement the technology. So this is another small example wherein the existing operating plant, we can increase the cutoff clearance of a fan. Any process fan, again, as I said, the 25% of the power is consumed by the fans. It is important to get the maximum efficiency of the fan. The efficiency of the fan depends on the cutoff clearance. If the cutoff clearance, which is the gap between the impeller and the casing, if it is on a higher side, there will be a lot of recirculation, and that will lead to more power consumption or loss of power. So these are the studies in that particular plant. In a particular plant, the cutoff clearance was studied, and then the plant had an in-house capability, and they were able to reduce the gap, and they were able to achieve a good saving. So here again, the saving potential was 100 kilowatt per hour, even with the 2% efficiency improvement. This can be done by in-house team and doesn't need major investment. The savings is significant. The payback period is very attractive. So these are the few case studies which I wanted to share. So I hope this would have made some sense to you, and we will be very happy. We will be very glad to share all the information. And CII being an industry association, not for profit organization, we also have all our case studies, publications available in our website. I'm sorry, I have to go for another meeting. So I hope this recording is also recorded, and we'll also share this presentation. Through our partner, we'll be very glad to answer any of your questions. I'm sorry, I'll not be able to join further. So I will request my colleague to take over here. Thank you very much. Thanks for your patient listening. Thank you very much.
Thank you, sir.
Thank you, Murali, sir.
All right, thank you so much, Sir Murali. Now I'm turning it over to our next speaker, Mr. Sougata.
Yes.
Thank you, Sir Sougata.
Yeah, I'm just sharing my screen. Yes. My screen is visible.
Yeah.
Just make it full screen. Thank you so much. Good afternoon, all. My name is Sougata Sarkar. So I'll be talking about few case studies implemented in Indian steel industry. If you see Indian steel industry, India is the second largest producer of steel in the world. Last year we produced around 150 million tons steel, crude steel. And also, if you see Indian steel plant, there are majorly three types of steel, which are having a blast furnace, sinter plant, coke oven plant, and then steel melting shop, caster, and the rolling mills. Then around 15 plants are there. Large groups are also there. And then we have around 280 plus sponge iron unit or DRA plants. And we have secondary rolling mills, around 1200 plus secondary rolling mills. And if you see the energy consumption, specific energy consumption in Indian steel industry, particularly integrated steel plant, it is around 6 to 6.6 gigacal per ton of crude steel. And if we talk about the CO2 emission, that is 1.8 to 3 tons of CO2 per ton of crude steel. So in this presentation, we have captured some of the good case studies that are implemented by the Indian steel plant, and that we wanted to present in front of you. So these are the few case studies we wanted to share. Like first case study is that revamping of the cold rolling mill. You know, Indian steel industry is very old, around 50, 60 years old organizations. And that time people are using DC drives, DC drives for their rolling mill areas. But though DC drive in place of DC, presently now AC drives are available, which are more efficient and speed control is very possible in smoothly. So if you see one plant, they have replaced their cold rolling mills, which are running on DC drives, and that time power consumption was around 70 kWh per ton of production. But they, after that 1 year project, they have implemented and they have spent around 60 crores rupees and replaced their AC drives with the DC drives. And their power consumption has reduced by 5 kWh. The presently power consumption is 65 kWh per ton of production. It's a huge project and investment is very high, but at the same time, the savings also very high. So what they did during these changes, they have changed all their DC motors, which are very costly motors, and at the same time maintenance is very difficult. So they have changed it to AC motors. And they have not only replaced the AC motors just one-to-one, they have also used the energy efficient motors, I3, I4 get energy efficient motor they have installed. They have also increased the speed 450 to 400 RPM because of the demand of that production, and it increased their productivity and AC drives. And wherever possible, they have also installed level 2 automation. And because of that, they have saved energy, good amount of energy they have saved annually, around 1250 gigacal per annum for their plant. This is one of the project. Maybe I'm not very aware. I'm not aware of this steel plant in Philippines. Maybe you will have most the secondary rolling mills. If the most you have the second rolling mills, then if you are using steel running on the DC drives, then there also you can change into AC drive, and you can reduce substantial amount of energy and also save the cost. Now, second project is that in our country, mostly we have large number of transformers, critical, non-critical transformer in our steel plant. So what the people are presently using, they are using the mineral oil. Okay, and again, that is the natural resources, and also there's a high maintenance cost involved if you have transformer, oil-based transformer. Now, what people are doing now, they are replacing their oil-based transformer into dry transformer, amorphous dry transformer they are using. So what is leakage and maintenance-free transformer? So the cost is reducing, at the same time we are saving also mineral oil. So there's a huge potential is also there in the different plant, whether you are from the steel plant or you are from cement plant or it is a fertilizer plant, anywhere people are still using. I hope country you are also using oil-based transformer. So those transformer you can also think about how you can do with the dry type transformer. So this is another project implemented by another one company, and all this information are available in CIGBC website. If you need more information on this, you can contact us or you can directly contact the company and we can share with you. Then third project is that blast furnace gas TRT installation. That is related to project related to integrated steel plant. The integrated steel plant, they will have the blast furnace, and when the where iron ore is reduced to liquid iron. So when it is producing the liquid iron, it also generates substantial amount of blast furnace gas at high pressure. So that pressure further can be utilized with a microwave, and you can through alternator you can generate the power. Like this plant, their hot metal production or their steel production, liquid iron production is around 8,000 tons per day, and top pressure is around 2.5 kg. It is very high. So what they did, they installed a topic gas recovery turbine. So they reduced the pressure from 2.5 to 0.5 bar, and because of that, they have generated 14 megawatt of power. It's a huge quantity of power they are generating. Only that, just utilizing that pressure. So because of that, they are generating this, getting this power from this top recovery turbine. So they are not now taking the power, that 14 or 15 megawatt power from the grid. So it is reduce that overall energy consumption of the plant. It will reduce their cost, overall cost of the plant, and also reduce the CO2 emission, because you are now using all the pressure. Using the pressure, you are generating the electricity. So this is also another good project. Most of the steel plant in India, they are following, implementing this project. Or new plant is coming up. They are also going at this TRT or top gas recovery turbine. One of the project implemented and they are presented during our energy award program happened in Hyderabad. Now, next case study is that your specific power consumption in the induction furnace. If you have a secondary rolling mill, definitely you have a steel melting shop. And in the steel melting shop, people are using mostly the induction furnace for melting your scrap or melting your DRI. So during that time, generally they use they don't know what is the actual power is required for melting this scrap. So that is why one company, they have developed a new system, that is a new power controller system. They have developed an allowable load cell. So this load cell will sense the actual weight of the scrap, and based on that, it will give the actual what is the actual amount of power to be sent for melting this scrap. So thereby properly manage, they are optimizing their energy power consumption, and thereby they are saving the electricity. And as they are reducing their electricity consumption, so their specific power consumption is also reducing. Also, as they are reducing their electricity consumption, which are taking from the grid, so their greenhouse gas emission also it is reducing. And this kind of project induction project is applicable for across any sector wherever people are using induction furnace. There it is very much possible, particularly in India, 1200 plus secondary rolling mills are there. So they have that own steel melting shop, and there have induction furnace 5 ton, 10 ton, 12 ton. And this project has a huge potential that if the companies implement this system, they will save their electricity consumption drastically. So that is another project presented. All these case studies we are talking about, all the presented, implemented case study. It is not that something we are talking about, okay, some new ideas or new project, maybe in future it will come up. So all these case studies are already implemented, and they have substantially reduced the power consumption. Then another project we talk about that in blast furnace area, there are the hot stoves. So that stove surface and hot blast pan, generally people do not no coating is there. So what is happening? The average surface temperature and that hot blast and stoves is around 115 degree or 30 degree. There's a huge amount of actually energy wastage. So what they have proposed, one company, what they did, that they have given a special type of coat that is ceramic thermal coating. So because of that coating, it reduces that temperature. It reduces the temperature brought down to 50 to 60 degrees centigrade, and thereby they are saving the fuel consumption in the blast furnace. So they have reduced around temperature of fuel heat around 1200 million kilocalorie kcal per annum. So this is another innovative technology companies. They are manufacturing this coating, and it's this type of coating can be used in any industry where heat radiation loss is there. So this type of coating can be used particularly in the steel industry, forging industry, then your automotive industry. This type of coating can be possible. And this the range is the material range is minus 1800 degree, minus 18 degree to 1800 plus degree temperature it can withstand. Now, next, these are the few of the case studies we wanted to share with all of you that steel plant people have implemented, but there are several other case studies also. Now, in the steel plant, I'm giving example that people are using MEMB drives, medium frequency drives, for their fans, pumps, blowers. That is a very common project now has become for the industry to implement that medium voltage drives. Then people are also installing various kind of industrial automation. Industry 4.0, that is also they are implementing, and people are going ahead with the implementation of ISO 50001 certification, that energy management certification, and that properly way they are managing their that energy consumption. Because India energy cost is very high, particularly in the steel industry. If you see whether it is a DRI plant or it is a integrated steel plant, energy cost almost 40 to 50%, including all type of fuels, whether it is coal, coke, gel, or it is electricity. So that is why, though our consumption is little on higher side, 6 to 6 gigacal, but some of the good plants are really there, like Tata Steel is there, JSW Steel is there, SAIL units are there. They are really an efficient plant. Their plants are very green plant. So now we'll talk about some of the latest technology related to energy efficiency and resource conservation. So in India, the number of startups are coming up. Okay, startups, they are working on the clean tech domain. So they are working on energy efficiency, water management, waste management, renewable energy generation, green product, IoT solution. So they are coming on latest innovative technology, and which are now applicable for any kind of industry, whether the steel, cement, paper, power, any kind of industry. This type of technologies are available. So we want to share a few of the technologies, and maybe we can discuss in detail when we come to Manila next month. So we can talk about more on that. We can share more info on these technologies.
Hi,
So
Sir Sougata.
Yeah.
Yeah, hi, sir. I think your camera is off, or does it have any problems? Yeah.
Camera?
Yeah, it's good now.
Yeah.
All right.
Okay,
Thank you,
fine.
sir. Okay.
Thank you. Sorry, I missed it. So next is that our new smart sensor for the motor. Generally, we install the motors, we take only the voltage or current, and we take the power consumption. But new kind of motors are there, new kind of sensors are there, smart conditioning monitoring. So what is the water temperature, what is the vibration level, what is the kilowatt it is taking, all this information you can capture at one place. And that is not in only your NCC room or PCC room, you can take it at your office also. You can see which of the motors are running, what is their condition, what is the loading part, and based on that you can take the decision whether that motor is consuming more power or motor is any maintenance is required in that particular motor. So this kind of sensors are available in the market, and this also increase your efficiency by 5%. Also, as you are predicting that what is the status of particular motor, you can reduce their breakdown. Also, you can save that replace motor before they break down. Okay, and because of that, also that extend lifetime motor by as much as 20 to 30% life of the motor getting extended. So this is also another innovative technology now being implemented by the Indian industry, particularly for the engineering industry. Now, second is that high efficiency solar bifacial solar panel. Now, generally, you know that the conventional solar PV that it generates power from one side, but the bifacial solar panel is another new technology, so it can generate power from backside of the panel also. So by which we can get another 10 to 15% more power compared to the conventional PV solar PV panels. Like in conventional solar panels, it may be 18 to 20% efficient, but this panels, because it is generating power from the backside simultaneously, you will get for 3 to 5% more efficient. And in this type of panels, this is a Swedish technology. They initially developed this technology, and we CII at GBC at Hyderabad office, we also installed this 135 kilowatt panel in our on our rooftop. And also that is why we are now getting more power, and we have converted our existing building, green building, in a net zero building. So now in India, we have seen now all the steel plant, particularly big steel plant, they are going at with the renewable energy. So wherever land is there possible, so they are going at the big 3 megawatt, 5 megawatt, solar power plant. Then on the rooftop available, on the rooftop also they are putting solar panels. At least they are trying to save some amount of energy in their process. Okay. Third is that a frictionless coating system. That is another technology, that whatever pumping system we have, in steel industry for cooling system, we need large number of pumps. So for pumps, if the pumps are very old, there's because of that old age, the friction issues are there. So now the special type of coating systems are available. If you coat with inside that particular pumps or their impellers, you give the coatings, so it will increase the efficiency. At least 2 to 3% improvement in the pump efficiency are reported. Because when you buy a pump, you cannot replace it until maybe after 20 or 30 years only you will replace. But before that, if there is an issue is there pump, you can increase the efficiency by putting this coating system. So this that frictionless coating system is applicable. Potential areas are particularly for the cement sector, steel sector, where you using large number of pumps like power plant pumping system, WHR section, then the fans and the river water pipelines. So there we can use this special type of coating system to reduce the friction loss. So these are some of the pumps, and in condensation water pumps, then boiler feed water pumps. So people have used this special type of coating system, and it is not highly efficient. % efficiency you see in observe, and you can see in the reduction in the electric power consumption. Then another new technology is the waste heat recovery from the compressor. Compressor is the major energy intensive equipment in the industry, whether it is steel, cement, paper. It is consuming very high power. Okay, but whether you are giving 100% power, but actual useful energy only 10 to 15%. So most of the power, most of the energy in the form of heat, it is thrown to atmosphere. So that atmosphere, you can, if you put a heat exchanger and you can capture that heat you can use to preheat your hot water. Maybe that hot water can be used for your boiler system. Maybe you can use for space heating. Maybe you can use it for your chiller system. So now this is a new type of technology, particularly in many engineering industry and many steel industry. They are going at with this heat recovery from the compressor. Okay, if you have the oil lubricated compressor, putting on a heat recovery system, PAG system, and therefore they are getting that hot water, and that hot water they are using in the boiler feed water, or they are utilizing it for the space heating, or they are using it for hot water generation in the canteen. So that is not a highly capital incentive project, but it is a medium investment grade project, and you can easily implement in your plant. And there are several other companies that they are also developing this type of product. Then another innovative product is the EC fans. Generally, you have seen that our air conditioning unit, that air handling unit. So those are normal conventional blower only, but now EC fans are available. This was the brushless DC motor, and they are using the i5 grade motor. And that is why energy efficiency is very high, around 80 to 80% efficiency are achievable. We can achieve by installing this energy efficient, this type of BLDC motor. This is a conventional blower. You have a motor, you have an impeller, a blower, then you have power connection system, everything. But if you see that right side, it is a very compact system of BLDC or EC fan. So you can install a new AC fan in your system based on the requirement. Also, it can use as a retrofit project. So in conventional system, you have that cell, that AHU box. You can remove existing motors and you can put your conventional newly designed EC motor. So these are very efficient, around 80% efficiency there for EC fan. Then there are other several technologies are also there in India. I will not talk in detail about these technologies because of time. So like heat pump, energy efficient heat pumps are available in the market, which are giving 20% saving. Shakti, and this company name is, these are the Indian companies, Aspiration Energy, Shakti Pump, Affocuting. They are into L-Thermos energy efficient aluminum holding system. They are to reduce your power saving 50%. Then some companies are there, they are capturing that atmospheric water generator is there. They can generate the water from the atmosphere. It is applicable for commercial and domestic building sector. Then energy efficient synchronous motor, electrons motor is also there. That is around saving 50% in the energy saving in the conventional fans if you are using ceiling fan in your plant. Then Neveski is there. Their IoT platform is there for MSMEs. They can capture all type of energy. What is liquid, gas, electricity, then what is the compressor air monitoring system, then water monitoring system, everything you can see in a dashboard. So that type of saving system is also available, which you can save around 55% in energy saving. Then also regenerative burners are there for lateral preheater and for the steel industry. In the steel melting shop, there are also opportunities there. If you use the regenerative burner, around 18 to 20 per hour can be you can save, and that is applicable for mostly in the steel forging foundry industry. And also biodegradable plastics are there, that can be also as a replacement of plastic you can use. And now people are talking about the hydrogen, green hydrogen, utilizing the blast furnace in the SIS 101 plant. So those projects currently are on R&D stage, but very soon, another 5 to 7 years time, people will start using the green hydrogen in our process. Because the government of India has taken a target that will be using around 5 lakh megawatt solar power energy by 2030. So these are some of the technology like EV system, then green hydrogen, then energy storage system. These are the very upcoming technology in India. So very soon it will be implemented in different plants and will save energy industrially. So what we want to sum up here. So there are various opportunities are there, not only from only steel sector or cement sector. There are opportunities from different sector. Every sector is developing, and they are developing new technologies. And then there are new technology also now. Big plants they are also accepting, and they are adopting those new innovative technology. And energy manager and energy auditors also playing a vital role for the performance reduce the energy consumption of the plant. And we CII in every areas, every field. So if you need any support from CII, we'll be glad to assist in all possible ways. So this is a short program, short session where we have just talked about brief details of the various technologies. But when we come to Manila next month, maybe we can share more details. And in between, if you want to know about any technology, so you please write to Apex, and they can share with us, and we'll share all the information with you. Thank you.
All right. Thank you so much, Sir Sougata. Thank you as well to Sir Murali. So we really learned a lot from this insightful discussion. And so with that in mind, I hope you all enjoyed this discussion this afternoon. And now we are opening the floor for some questions for our webinar attendees as well. If you guys have, so you just drop your questions in the Zoom chat box, and our esteemed speakers shall be answering your questions to the best of their abilities. So due to the time limit that we have, if you will not be able to drop your messages or your questions. You can also drop your thoughts via our LinkedIn page or our Facebook page at Apex Global Learning, or email us at training@apexgloballearning.com. Sounds good? Can I please see a thumbs up for our attendees, please? All right, okay, thank you so much. Okay, so let me just reshare my screen because we have some exciting announcements just for you as well. Okay. All right, so before we end this session, we would also like to take this moment to introduce to you our new program specifically catered to energy efficiency. So the Energy Efficiency Practitioner Industrial Training. Just to give a bit of trivia, the Philippine government aims to increase renewable energy to 35% of the supply mix by 2030 and 50% by 2050, focusing on energy efficiency and new technologies for security. So with a need for an additional 52 gigawatt of power capacity by 2045, innovative solutions are crucial. So this two-day training covers energy management and efficiency, aligning with ISO 50001 2018 standards. Participants will learn to establish ISO-compliant energy management systems, identify significant energy uses, and set performance targets. The course equips professionals with practical skills to enhance energy efficiency in sectors like cement, power, steel, and pharmaceuticals using real-world case studies. So, what's in it for you upon enrollment? So by enrolling in this course, you will be able to gain expertise in ISO 50001 2018 energy management systems and the roles of energy managers in achieving efficiency standards. You will also be guaranteed a 16-hour classroom training led by industry experts, a well-designed training material with simulation activities, and of course, a certification on successful completion of training and assessment. And there's more. So we are offering up to 12% discount for the webinar attendees. For more details, you may contact us through this email, shirley@eccinternational.com. Okay, so thank you everyone for your participation for today's event. So to properly end this session, I am sending you this quick survey that we have for you. Okay, hold on, please. All right, so I'm sending it here on the chat box. There. Okay, so we request everyone to kindly fill this out, as this will generate important information that we could use for our next Xposiums and any topic of interest that you would like to tackle. Once again, thank you for attending our Xposium for today, only here at Apex Global Learning. And again, I would like to thank Mr. Murali and Mr. Sougata for your time and for sharing your thoughts and experiences with us. Have a wonderful day.
Thank you.
Happy Friday as well. Thank you so much.